allowing us to take a little bit of your time and talk to you in the idea community and our Illinois educators community about coding with drones, really integrating some amazing emerging technologies into the classroom. Before I jump off this introduction page where you can see some beautiful photos of Jenna and myself in black and white circles here, just want to give a little bit of my background as program coordinator. I am actually a trained engineer by profession. I graduated with a degree in mechanical engineering from the University of Michigan many years ago. And for the last 10 years, I've been working in STEM education and test prep. I'm really excited because with the Next Wave STEM, we've got an interesting opportunity to broaden the amount of exposure that students from all kinds of different backgrounds have in STEM generally, when we think about teaching science, technology, engineering, and mathematics with fidelity, but really specifically with using hands-on emerging technologies because those really capture our students' imagination, which gets at the core of what Next Wave STEM does. And to speak more to that, I think I want to talk a little bit more about who Next Wave STEM is and what our philosophy is as a whole. So instead of just reading off the screen, I can really tell you more of a deeper story. Next Wave STEM was founded with the goal of solving the world's biggest problems. And the way that we think about solving the world's biggest problems isn't us going out and hiring tons of engineers and product designers and physicists and astronomers and biologists and trying to solve these problems ourselves. We understand that there has to be a much more grassroots effort, a groundswell of engineering learners. We know for a fact that as early as the 1940s and actually much earlier than that, it's been a national priority and imperative to increase education efforts so that we can catch up when it comes to technology, thinking about geopolitical issues. The moonshot, the space race, was a direct response to the United States feeling as though we were falling behind when it comes to innovation and solving problems and expanding into future frontiers. And so they made college more affordable for students all over the country. Next Wave STEM, we realized that we have some massive problems that need solving in this decade, not just in this decade, but right now. We know that climate change is real, and there are climate refugees that are moving throughout the world and through the United States right now. There are hundreds of thousands of homes throughout the country that have problems with lead in the water supply. We're throwing away 30%, if not more, of the food that we grow and that we farm in this country every year. We're having mounting issues of all sorts that we have to solve, and we know that our young learners are going to grow into those problem solvers that we need. So for Next Wave STEM, it's about giving students confidence to engage with STEM, confidence to get hands-on with technology, confidence to make mistakes, because in making mistakes, they learn more and more and more. If you could distill what we really seek to do in Next Wave STEM is to introduce students of today to the technologies of tomorrow. So in doing that, we're providing curricula, guided curricula for teachers, K through 12th grade and emerging technologies like robotics, 3D printing. We're piloting a computer and AI course this fall, and we have a few courses that deal with drones and autonomous flight as well. So whenever we talk about having conversations like these, it's good to have a goal. We just don't want to talk aimlessly. We want to have an idea of what we want to get out of these conversations and what hopefully at the end of our talk today, you'll be able to take away from this conversation. So two things that I definitely hope that all of our participants on the line today take away, and hopefully we'll be able to encourage you if you're thinking about integrating drones into your classroom, or you're just looking for some really good ideas, really new ways to use drones in your classroom, regardless of the particular drone that you may be using. The first goal that we have, we really want to help our participants today understand how drones actually work, and in understanding how they work, how they can be used to support STEM learning across a few different subject silos, if you will. Drones are really powerful when we think about doing science. They are an advanced piece of technology, and if we want to understand more and more what our drones are doing, helping our students understanding more and more what their drones are doing, we'll need sometimes complex mathematical skills, but they also offer interesting engineering opportunities. Once we understand how drones function and how we can use them, of course, because we're educators, it's important for us to think about how we'll integrate this into the classroom in a holistic way when we think about 21st century skills, but also how we can even build lessons that will align with the next generation science standards. So we'll go through a quick little exercise where we talk about how we scaffold those performance tasks and how we could even assess when we think about what those next generation science standards are trying to accomplish. But that's just the things I want from our training today, the things that I hope that we can communicate with you. One thing I also want to encourage is for you to think about what you would like to get out of the training today. So we'll take maybe a minute and think about these two questions. What is your individual goal or goals for today's talk, and what do you hope to get out of the experience? The chat is open. So we might have a few of these moments where we'll just pause and give you a second to share with us and share with the community in the chat what you're hoping to get out of the training today. And hopefully we'll get a chance to cover that. But if not, we'll have a really, really fun, hopefully, hopefully fun Q&A session at the end of the talk. So yeah, I'll stop talking and I'll give us about 60 seconds. Go ahead and enter into the chat what you hope to get out of the training as well.
Okay, Desmond, as they come in, I'll read them off for you. I hope to get a clearer picture of how to integrate a drone coding unit into my classes, understand how drones affect students' futures, listening for ideas. As an FAA certified remote pilot, I'd like to build STEM curricula for K-12 educators in Illinois. That's cool. I would like to integrate coding into my library makerspace challenges.
Those are all amazing goals. Thanks for sharing. For our FAA certified UAV pilot, welcome. That's really, really cool that you've gone through that entire process. And I think that's going to give an opportunity for you to do some even more exciting things with your students in the classroom, because you've got that really fundamental background knowledge to operate drones safely. And that's something that's absolutely worth talking about when we think about integrating drones into our classrooms. So welcome to everyone. Thank you so much for those awesome goals. And I think that we're going to be able to accomplish quite a bit of those goals today. So I had a speech professor in the University of Michigan who said that you can always tell if you're going to be in a bad talk if they start to talk off with a definition. So we're not starting with a definition, but we got to give a definition. Hopefully this doesn't make for a bad talk. We're going to have a little bit of fun. We want to start off by defining a drone. And this idea of defining a drone is really relevant because the technology, when we think about drone technology, is really relatively young. The Oxford definition of drone is a remote controlled pilotless aircraft or missile. Really, generally, we're thinking about an unmanned aerial vehicle. So if you're like me, the first time that this word really proliferated in your local lexicon and really in our national discussion was in 2001. With the advent of the Iraq War, all of a sudden we were starting to hear more and more about these flying robots that were supporting troops in the conflict. More and more we had these questions about ethics. Is it right to be fighting wars where, at least from our end, there were less human lives in the way? Is it ethical to be piloting and using these machines, like you see in this picture, that are as large as conventional aircraft to deliver ordnance? What does that mean for the right way and the wrong way to use this technology? It seemed like a can of worms is really opened up. And a lot of those ethical questions that we have about the application of technology in this way is still very relevant today. It's been almost 20 years since the beginning of that conflict, and we still don't have answers. But the world of drone technology has not stagnated at this place. Drone technology was being developed for decades previously. When you think about remote controlled aircraft or remote controlled helicopters, RC has been available for people to use since the 1950s, the early 1950s. And it's kind of this natural progression when you think about piloted aircraft using autopilot, the advent of GPS technology, and more fine controls and microprocessors and transistors and radio and satellite technology, that we would get to a place where we could have aircraft pilot themselves. But we are also, as we see with all technology, starting to see these applications shrink smaller, smaller, and smaller. When you think about what a drone is, and that definition is a decent definition. It doesn't encapsulate everything what a drone is, but if we wanted to break it into bullet points, you could think of a drone as doing some simple things. Not necessarily what the form of a drone is, but what a drone does. A drone uses simple sensors to generally follow a simple directive to go from point A to point B, go from here to there. Everything else that a drone does is, for lack of a better phrase, just gravy. Whether it's taking pictures for a wedding, whether it is delivering ordnance to a war zone. The directive is to get the drone to a location, and everything else that happens is an added benefit. We see drones piloted using remote controls, much in the same vein as those RC craft of the past, but drones are also able to fly autonomously. Writing lines of computer code, we can make the drone fly and land by itself. So that's something we're going to talk a little bit more about later on. They range in size, equipment, and ability. We see drones that are as big as classrooms and conventional aircraft. We have seen drones being used that are the size of hummingbirds. And if we want to get technical, anything that we use in an aeronautic, even space application that we're not remote controlling, but it's controlling itself, will be a drone. A good example of that is the Mars InSight mission that landed on Mars last November. That is a spacecraft that traveled 6 million miles from Earth to Mars, took 6 months, and then had to land on Mars by itself. That is an extraterrestrial drone executing that kind of flight. So we see these drones coming in all different shapes and sizes. So I mentioned some of the applications for drones, and a lot of these applications are growing out this idea of drones finding their birth in the defense and military space. But because drones are coming in so many different sizes, and because the technology is also being democratized as prices get lower and lower and lower, we're seeing some more interesting applications for drones. One of our participants was wondering about what drones would mean for the futures of their students. And really the answer is how human tasks are going to change as they're being aided by this technology. So of course, we understand drones as military tools, both for surveillance and for actual ordnance. But we also are seeing drones being used in civilian applications increasingly. We're seeing many news stations and many local governments using drones to monitor traffic in real time. There are sensor systems that allow for this, but if we want to get a better idea of the way that cars are moving from the perspective of traffic flow actually being a flow, following ideas in fluid dynamics, drones are an amazing way to do that. More and more, we're hearing these discussions about actual parcel delivery. 2 years ago, almost 3 years ago, Amazon was granted its first license internationally to deliver drones. And in various US cities right now, if you're willing to pay an extra $30 to $40 on top of your Amazon Prime subscription and the price of whatever your object you're buying actually costs, you could spend and make sure that Amazon is delivering a package to you within 30 minutes using a drone. just as long as that package is about the size of a shoebox and weighs less than 5 pounds. But if I need something right now and I can't get to it, Amazon might have a solution for me that uses a drone. More and more, we're seeing NOAA and once again local weather stations, meteorologists using drones to monitor weather at the micro level, building much more robust examples of what's going on at that micro weather level, feeding into larger models. And of course, something really, really cool is firefighter applications. This bottom photo here in the slide is actually from I want to say, Belgian startup. A drone that uses 16 propellers to lift these very large battery packs, but these battery packs are there to power lifting of a large fire hose. When we think about fires like the Paradise Fires of last year that ravaged large parts of California, we're thinking about ways that drones might have been used to aid in those fire efforts. But really, we're thinking about as buildings grow larger and larger in dense urban areas, using drones to help enhance the safety of those buildings as well. So really what we're seeing are these drones being used in more public ways, whether it's monitoring traffic. One thing I didn't mention is law enforcement applications. More and more drones are being used to do law enforcement surveillance for the general populace. Is also a little bit controversial. But things like parcel delivery, doing science when we're watching the weather, fighting fires, all of these things are now being put towards the public good, even in public and private sector as well. The more that your students know how to use this technology, the more applicable this becomes for them as they're going on to their secondary education and to their post-secondary education. Who is going to dominate the delivery space? Who is going to be the person that makes firefighting a little bit safer when we think about developing drones for firefighting application? Who is the person that's going to be thinking really in depth about the ways that we can use drones to even do things with monitoring and repairing infrastructure? All of these things are going to become much more important as drone technology is refined more and more over time. So one reason that NextWaveSTEM is really, really excited about drone technology is that drones are being used more and more in computer science education. When we think about autonomous flight, that's really a fancy way of saying making a drone fly not necessarily by itself, but according to a set of instructions. We are big fans of different manufacturers who are making drones that are able to be coded and programmed. The drone technology that we use at NextWaveSTEM is called Tello. It is an education drone that's manufactured by DJI. DJI is one of the leading manufacturers of drones in the world. I think last year they did $5 billion in revenues. A lot of us are familiar with Parrot drones. Some of us have used the AirHogs drone system as well. Some of us have used MateBlock drones. There are many options for us, but what they have in common, most of them have in common, is this ability to integrate these ideas in computer science. What's really, really fun about integrating drones into the classroom is that once upon a time, we thought that you had to be a really, really, really advanced computer scientist in terms of being an advanced coder or someone who really understood and could dig into the weeds of computer science and working with technology to program a drone, but that's no longer the case. Right now, lots of these platforms allow you to program using Scratch. And I'll talk about Scratch in a little bit, but if you're not familiar with Scratch, it's literally drag and drop. You're selecting blocks of code and you're pasting them together on a tablet, on an iPad, on your computer, and then the drone will execute that flight as well. In that same vein, for some of our students who may be learning some basic computer science languages, drones are now being able to be coded using Python. For those of us who are familiar with Python, it's now becoming the most widely taught computer science language at the high school level. Once upon a time, that used to be C++, and then for a while it was JavaScript, and now that's been supplanted by Python. So more and more we're seeing these technologies become easier for our students to use, easier for our teachers to teach if they've got a computer science background, and something that our students are going to be able to display some interesting ideas at with our students over time. So I love Scratch. I'm a huge, huge Scratch fan. Some of us may be familiar with Scratch when we think about Hour of Code, or even coding, building games with our students. If we've done any of that computer science before, Khan Academy has a program that introduces students to both JavaScript and Scratch as well. Just for a little bit of history, a little bit of background lesson, Scratch was born out of the MIT Media Lab in 2002, and the amazing thing about Scratch is that it was designed with language learners and computer science learners in mind. It's free and it's open source, which means that if you want to use Scratch, you'll never ever have to worry about paying for Scratch coding on your devices. Your students of really any age are able to practice and modify using Scratch because it is block-based. You don't have to worry about typing out the commands exactly right. You don't have to worry about putting the semicolon in the wrong place or not having a bracket closing in the command. It's drag and drop. As long as the lines of code are connected to each other, then your code will run and they will operate. And it's really, really fun because it allows us to do some really, really complex things if we're willing to put some time in. We have seen video games, robust video games designed in Scratch. One thing that I didn't include in the talk today was actually a student who programmed a version of Super Mario Brothers, the original Super Mario Brothers that ran using nothing but Scratch coding. Now it was robust. We're talking about thousands of lines of code, but they didn't have to type any of it. It was complete drag and drop. And by understanding sequential logic and understanding just coding logic in general, they were able to build something that was moderately playable. It wasn't the best thing in the world, but Scratch offers a really easy point of entry for our students to build their code and will interface with our drones. So when we think about Scratch, our pros are that they're approachable. It's approachable in terms of a coding language. You don't ever have to have done any kind of code ever before. When I do PDs with teachers, I hope that I have teachers who've never coded before, because Scratch is a beautiful gateway drug into the world of coding. Now the cons of Scratch is that it is a visual UI. You're dragging and dropping blocks. That's very, very uncommon. There are not very many languages that will allow for that kind of programming. So if you're thinking of going into your coding, you're going to need to learn a new methodology. When you've learned something like JavaScript or Python later on, where you are doing a lot more writing, but that's designed for older students. The ideas of the logic, the programmatic and decision-making processes that have to happen are the same. Another con with Scratch is that there is no built-in data storage capability in Scratch. That means that if I want to use Scratch to make a notebook to save my work, that's not the best application, because there's nothing that's going to point towards storage or nothing that's going to let you load a save game natively. You can kind of hack around in there and get your processes to store. Programs we're coding in the drone that have built in some data storage and even cloud storage are really, really interesting, really fun things to try to get around to if you are a programmer, but they can be buggy. Got a really good question here. Desmond, can you use Scratch code with the Parrot Mambos? I have used a Parrot Mambo before. I believe that there is a version of Scratch that does work with the Parrot Mambo. Now, the thing about Scratch is that it's open source, so it's often modified from the bare bones original version. A really good analogy that I can think of off the top of my head is for those of us who have smartphones, which at this point is most of us, the Android operating system, if you're an Android user. There is a stock Android version that Google licenses for different manufacturers to use. But if you've ever picked up a phone that's made by Samsung, and then you pick up another phone that's made by LG, or you pick up a phone that's made by Google itself, it's all Android, but it all looks different. And that's because it is open source. And that means that I can jump into the code and change things. I can change the way things look. I can change the way things function and the way that they operate to a certain extent. Scratch is the same way. So my basic understanding is that Parrot has a version of Scratch available as well. That means as you move across different platforms, your version of Scratch may be a bit different. That will depend on the capability of the drone. That will depend on the actual functionality of the programming done in that version of Scratch. But it can differ from program to program. Really, really good question. Okay. So now what's really important to think about here is considering our students and our students' experiences. I want to take a moment and literally just another moment and have us consider these questions that are put up on the screen. 3 questions. Are there any parts of drones that we might consider dangerous? The drones that we looked at so far are quadcopters, and before we start with this, before I talk more into the safety aspect, I do want to give us a chance to think about it and kind of be critical. The second question, how would working in teams enhance or diminish the experience for our students? And that's going to get more into our idea of holistic teaching with drones, but also how we'll talk to 21st century skills. And then aha moments. If you've ever flown a drone before, the first time that drone took off, there were some definite aha moments. And if you've never flown a drone before, think of it being akin to maybe riding on an airplane or flying an airplane if you are a pilot. What are those aha moments your students are going to have? So the chat is open, and we'll give it another 60 seconds for you to answer some of those questions in the chat box now.
Okay, Desmond, we have someone who'd like to have their students use drones to solve societal problems.
Oh, that's a really, really interesting thing to consider because we have to define what the societal problems are. So I'm hearing a amazing project-based learning opportunity.
Aha moments will come as students learn to control the drone. They generally don't understand roll, pitch, and yaw.
Oh, yes, that's a huge one. So thanks so much for that input, some of those answers to those questions. I agree 100% with those aha moments. The idea of understanding how objects move in space, in 3D Cartesian space, is something that will become very important to your students as they're learning to control the drone, whether that's flying it remotely with remote control or flying autonomously, even more so flying autonomously. The idea of being able to talk about which way is forward, which way is backward, what's left, right, up, and down, to establish those coordinates and then be able to describe them mathematically, thinking about numbers and angle sense, is really, really quickly developed when students are flying drones and are flying drones autonomously and don't want those drones to be constantly running into walls, into shells, and into each other. Students really pick up on that very, very quickly. One thing I want to speak to about drones, when we think about safety, anything that we might consider dangerous, the drone that we use, the Tello DJI, it's about 8 ounces. And if I could compare it to the size of anything, I'd say a salad plate, not very, very big. Our drones, actually, we almost exclusively fly indoors. And that's really easy for us because our drones are tough. I have personally flown them into walls hard. They only have a top speed of about 10-ish miles per hour. And they have a battery life of about 12 minutes. I have flown these drones into myself. Unfortunately, I have hit children, even small children with those drones. And the worst injury that we've had is a drone that got caught in a girl's hair and the drone propeller pops right off. So we didn't even have to do any emergency barbering. It was a really easy experience. One thing that we do re-emphasize over and over again for our students is treating the technology with respect, however. Because your smaller drones, your DJI Telos, your Parrots, are not going to hurt your students by and large because of how small they are. Um, it can be, there's some temptation to not treat them with the respect that they deserve. Larger drones, also made by DJI, for example, they have a $1,500 drone called the Mavic. That drone is much more substantial. It's about the size of a turkey and has the ability to fly thousands of feet into the air. As those propellers are spinning, those propellers have the ability to take fingertips off. So one thing that we're always teaching our students is that it's important to respect the drone, to not try to grab the drone, to treat it like it's an actual aircraft, that you wouldn't try to grab an aircraft or run into an aircraft or knock an aircraft out of the air while it's flying, because it can be dangerous. We use these drones and we teach students as young as kindergartners that it's important to respect the drones, especially the propellers. That's the most dangerous part of a drone, even though those propellers for our kindergartners aren't dangerous at all. As long as we're respecting this technology, we can safely and effectively use the drones in the classroom. I know some of us have some students who are super high energy, who are ready to jump in and be excited with the technology. But as long as we take our time, set those expectations that the drone is a piece of technology that we have to respect, and that if we don't respect it, it could potentially be harmful to us, we will never have a problem with our drones. The second idea of working in teams to enhance or diminish the experience for students is the question of computer science. But the great thing about computer science is that we get a chance to work collaboratively, not just in using the technology when it comes to operating the drone or coding, but in both. Some of your students will want to code exclusively. They'll say, okay, this is my tablet, even though it's not their tablet. They'll say, this is my tablet, this is my code. I'm going to write all of the code and execute the code. Some of the students will just want to fly manually. They want to make the drone flip and fly and do amazing things and run through obstacle courses. It's a good opportunity for students to get a little bit out of their comfort zone and take turns in different roles. Whether that's coding the drone, whether it's making sure the drone is operating safely and recovery of the drone, or whether it is recording data if we're using the drone in a science lesson. All of these things are really, really interesting opportunities for our students to learn across these dynamics. And the huge aha moments, I agree 100% that seeing the drone fly in the air, moving through 3D space is such an incredibly robust aha moment. So one thing that's really important is to think about ways that we can think about how we brainstorm performance tasks and instructions with the drones. How do we integrate these drones into a unit? What does that actually look like? How do we get this idea of, okay, here is what we want to teach, here's what we want to assess, and here's how my drones can help us assess that. There are a couple of different really robust things that we can do that are just ideas to get our juices flowing, but we've seen have worked really well. And some of these ideas that we will be looking to integrate into our curriculum more and more. These things are integrated into our curriculum right now in a lot of instances as well. So the first thing I want to do is talk about the next generation science standards and engineering practices and some of these things, these concepts that will be enhanced by using our drones. And these are ideas that will build into our lessons as we scaffold, no matter whether we're working with elementary students, middle school students, or high school students. Working with drones is going to give us a great opportunity to ask questions while we're defining problems. That is step one of the engineering design process. So for some of us who are thinking about ways to use drones to solve societal problems, it starts with defining what the problem is. If we know what our problem is, then we are that one step closer to getting to a solution, a product or a process that's going to help us solve that problem. As we're developing and using models and carrying out investigations, that's really our ideas of gathering data that will connect directly to our scientific process. But we're also going to be doing some mathematical thinking when we're analyzing and interpreting that data. As an undergraduate, and even as in my post-undergraduate career, engineers have struggled to communicate with people who are not engineers. If you've got clients, if we have users, if we've got people whose lives we are trying to change and problems that we want to solve, we also need to be able to listen to and communicate with those people. So as we're communicating and interpreting data, making our scientific and mathematical findings real for people, we got to practice those skills, and drones give us an opportunity to do that. As we're constructing explanations and design solutions, that's really, really fun because it's about process with our drones. If we're solving and we're really creating analogies for solving bigger problems like medicine distribution or pinpoint agriculture, or trying to solve even a basic problem. Say we want to do cartography and make maps. I should say a more basic problem because that's actually kind of robust. We have to be thinking about ways that we can construct the explanation, design, the solution for those problems. Was really, really fun. Going back to that scientific method is engaging in arguments from our evidence. How good a job can we do at gaining evidence using that technology, whether that's a camera or sensors like a gyroscope or a barometer on a drone, and how can we then communicate those findings and all kinds of information to fellow students, to parents, really to any stakeholder. Our drones are going to give us an amazing opportunity to do all of those things. So what I've done in the next few slides is I've actually picked out a few standards that fall at different age distributions for our students. I've picked one for our primary school students, a second for our middle school students, and a third for our high school students. And when we're thinking about designing instruction, assessment, and then doing backwards design to the performance tasks, it's important to take two questions in mind during those times. How will we assess these standards, and what tasks will we scaffold leading up to the assessment and performance tasks? I have picked these not completely arbitrarily, but kind of to my preference to show a diversity of different ways that drones are used in STEM learning. A lot of these will do with more what we think of as traditional science disciplines, whether that's in energy or emotional stability, but I think there also might be an engineering standard packed in there as well. So let's take a look at this first one, designed for the elementary school age. It's about motions and stability, dealing with forces and interactions. It says that we'll need to plan and conduct an investigation to provide evidence of the effects of balanced and unbalanced forces on the motion of an object. So the question here is, how do we assess? How do students prove to us that they can conduct this investigation where they're providing evidence? How do they provide that evidence? How do we receive that evidence about the effects of balanced and unbalanced forces on the motion of an object? Well, we put an object in motion, that will be our drone. Drones, really good drones, effective drones, will have the ability to hover in space, and if they're hovering in space untouched, are not going to move and drift all over the place. You know, you can very easily tell the difference between a quality drone and a drone that still needs quite a bit of work by its ability to hover. If you have the drone take off and don't touch the controls, the drone should just sit there motionless in the air. If your drone is drifting, if it's going up, if it's going to the side, if it's coming back down, that means that that might not have been the best investment that we want to make with our drone. From that perspective, now we have the ability to investigate, okay, what happens if I introduce some new forces to our drones? Because our drone is hovering, it's producing a force to stay in the air that's counter to gravity. If I bring in a hair dryer and blow on the side of the drone, what happens? Our Tello drone is actually really interesting in that it self-stabilizes. It uses this gyroscope, very, very similar to what you'll find in a cell phone, and it will correct for random gusts in the air. So you'll actually see the drone fight against a force pushing back against it. How do students prove to us that they understand the motion of the object and the forces pushing back? Well, that means that we're going to have to take some evidence. If I put a marker from where the drone lands and I apply some forces, I'm blowing with blow dryers, I'm having my students blow with their mouths, I am introducing other destabilizing forces. For example, if I tap on the drone, if I use something like a ruler to tap the drone and try to move the drone, thereby applying a force, and then comparing where the drone lands. Now we've got something that we can measure. We can talk about a distance that the drone has traveled. We may not be able to measure force accurately, but that's another performance task that we can take, measuring the force of a blow dryer and then talking about force vectors. So we can see how something relatively simple, when we think about applying a force to a drone, can turn into a multi-tier lesson or even unit where we think about forces and how they affect things like flight. Something I haven't tried and I probably wouldn't be a huge fan of trying, but I might try, is what would happen if I took my blow dryer, my hair dryer, and blew it underneath the drone as it's flying. Am I going to fly my drone right up into the ceiling? I've done it before. Will it again? I don't know. That's something that we all have to explore. So really, we have this bigger investigation going on. A chance to practice some project-based learning skills for our students, even in that middle school age band. And we have these other tests where we're examining the different portions of the larger test. That scaffolds up to the performance task, and then our students will have to be able to prove something and tell us about what they learned in their investigation. Just a brief example, and we'll do 2 more, just being conscious of the time. For our 6th graders to 8th graders, our middle school students, this one is dealing with physics and it deals with energy. Students have to construct and interpret graphical displays of data to describe the relationships of kinetic energy to the mass of an object and to the speed of an object. This is so much fun. Something that I'm really excited to do and introduce with our students is not only constructing these graphical displays where they're talking about the mass of our drone and how fast it is, but comparing even that real world data analysis and how close that is to what our drone is recording about itself as well. One thing that's available on the Tello drone that we use in our course is a graphical display of what's going into our sensors. Our companion coding application will actually tell us what the sensors are spitting out from our drone. That means if I set the drone up and I start flying the drone, the display will tell me how fast the drone is moving in all the directions, X being forward and backward, Y being left and right, Z being up and down. It will tell me about the angle of tilt of the drone. So if the drone is rotated, it will tell me by how much, or if the drone is tilted on any of those axes going in any direction, it will let me know that as well. And it will do the best that it can, a calculation of its speed. So using information from the gyroscope, using information from the motors, it will do some calculations and tell you how fast it's moving, which is really cool and gives us a lot of this information that we have. So we have the ability to take the information that's being displayed on us. We can do things like taking screenshots or recording that information at particular time points. Once again, just concepts of scientific method and making sure that we're recording that information. We can also do a comparison. We can break out our stopwatches, we can break out our rulers, and we can compare how fast our drone is moving. That's just a distance divided by time, gives us a velocity. Really, really helpful skill to say, okay, is what we're seeing in our drone accurate? Are we taking accurate measurements? So we've got a couple of different things we can do there. that's flying the drone in particular ways to test the speed of the drone, to test capabilities and recording those things and then graphing them. We also have the opportunity to compare the data that we collect digitally from the drone sensors specifically, and then manually using our own powers or observations, which will be rulers and stopwatches and taking distance and time measurements and even weight measurements so that we can calculate mass. Once again, lots of really interesting things that we can do to scaffold to build up to that standard as well. And then we would think about the high schoolers. Really, really fun stuff here because this gets them thinking in the mode of solving some of those problems and thinking more holistically about the way that we might use our drone and the way that drones might impact actual people. So our 9 through 12 high school life science standard is about ecosystems, specifically dealing with interactions, energy, and dynamics. In the standard, students will have to design, evaluate, and refine a solution for reducing the impacts of human activities on their environment and biodiversity. So right away, this is screaming at us project-based learning opportunity. When we think about designing and evaluating and then refining, students really ideally will go through a entire engineering design process, from identifying the problem to doing research on problems, on solutions, and more research on the problem itself that people have already tried. From that point, they will then design the solution. They'll have to test that solution to get feedback, and then refine that solution to make it better. It'll be at least one iteration of that engineering design cycle that students will have to go through in order to satisfy this standard. Now, the really interesting part of the standard is that the solution is about reducing the impacts of human activities on environment and biodiversity. So there's some really important understanding that we have to have about how we're impacting the environment. A good example that I can think of, again, I think it might have been one of our participants who put this in the chat earlier, is about agriculture. Crop dusting is something that has been controversial for decades because of overspray, because of the use of pesticides. We're hearing about fields that are getting sprayed with pesticides that they never intended to be sprayed with pesticides. Will a drone solution allow us to limit our impact on the environment by decreasing the amount of overspray? Will it increase biodiversity by not having having more targeted application of pesticides, thereby killing less plants that we don't want to kill? We understand that pesticides are a way to decrease biodiversity, so we can use less pesticides. Inversely, we should increase biodiversity. So really what we're seeing here is students thinking through a scenario that way, thinking about designing a way to actually disperse or pesticides or some kind of agent, because I don't think you might have easy access to pesticides to be able to test this engineering solution. You might, you might be able to come up with something much more natural. And then taking that information and saying, okay, is this something that's workable? Or is this the stepping stone to a larger solution? All of these different ideas will wrap up together and the drone becomes the focus. How do I change and use the drone? And sometimes even an abstraction. Can I even program the pattern autonomously for the drone to fly in that will allow for the precise distribution of a pesticide like we discussed? The opportunities really become endless as we think about things that we have to solve or things that we just want to make better. So I know I've done a lot of talking, and this talking so far, when you think about assessment and scaffolding, has been about satisfying the next generation science standards, because we know of how important that is to make sure that our students are ready for the next level. Next generation science standards helps us get there, but it's also important to think about integrating any new technology into our classroom with respect to holistic learning for our students that are in the classroom. One really good way to think about that is the 21st century skills. And those skills are generally siloed into three distinct but overlapping skill sets: learning skills, literacy skills, and life skills. When we think about that, learning skills, we're really trying to enhance critical thinking, creativity, collaboration, and communication. Literacy skills covers the kind of literacy that we know is going to be important for students as they grow into 21st century learners, but actually 21st century doers and problem solvers. So we know that students are going to need information literacy. They'll need media literacy, and they'll need technology literacy. And working with a drone is certainly something that's going to build that technology literacy. And then our students are also going to learn life skills. Being an engineering student, studying engineering techniques is something that also enhances or has a large potential to enhance some of those life skills. So will students learn how to be flexible if something goes wrong? Will they learn how to be leaders and know what good leadership looks like, considering that any major solution to our problems is never a solo act? They will have to work in teams. Will they be able to show initiative, identify problems, think critically and sometimes even harshly about what is and what's not working? Will they show the ability to be productive and think about increasing productivity? And will those social skills increase? Can they communicate with each other, have conflict with each other, and make resolutions with each other? All these things, all these concepts, all these skills are really important and really engaging in our drones, working with our drones, coding with our drones, learning with our drones, troubleshooting our drones gives us the ability to enhance these skills in really, really robust ways. So just another quick question, and I am glancing at the time, just making sure that we have enough time to at least give a little bit of Q&A. Thinking about specific ways that using drones in the classroom supports development across the 4 C's in those learning skills: communication, collaboration, critical thinking, and creativity. It's about the engineering design process and how building the experience with drones, coding the drones, and autonomous flight, and working specifically together in teams will mean that we're going to run into some huge problems that we may not have the answer for right away, that we have to engage in collaboration about, that we'll have to get more information from a lot of outside different sources, from our other team members, from our instructors, from resources that neither our team members or instructors has engaged with previously. It's a really, really interesting opportunity if we've got the courage. I'm going to add another C. If we've got the courage to allow our students to struggle a little bit and fight through the struggles to reach some of those other aha moments. So this is the penultimate slide where we think about the goals for our training. And you guys on the line today, guys and gals on the line today, can let us know how we did and what you want to see more. So the chat is open for you to throw some comments up or questions as we transition into the Q&A. Did we help you understand how drones work and how they can be used in the classroom? Did we identify those practical approaches when we think about scaffolding and building in our assessments for 21st century standards, and really thinking about those 21st century skills? And do you think that you got a chance to get some of those individual goals met, whether that's just getting some ideas, whether it's learning more specifically about your particular drone platform, whatever it may be? We'll give it just a minute if you want to add anything about the goals for today's training. And no comment is a bad comment. I love criticism. That's a way for us to get better. So let us know what worked and what didn't.
If you have any questions still for Desmond, this would be the great opportunity to put those in there as well. Desmond, does anyone know if there is a curricula already created and implemented in any school districts?
The
Anybody
answer,
out there, if you have an answer to that, or Desmond, if you do?
the answer to that is yes. Once again, shameless plug. Next Wave STEM, we have developed curricula that integrates drone flight for K through 2 and 3rd through 8th grade students. If you're interested in learning more about our curricula, you can reach out to us. We are www.nextwavestem.com. You can also reach out to me, Desmond at NextWaveSTEM, and we will get you in contact with the right people. We have also done high school curricula as well. So just let us know. We'll try to get you in touch in the right direction.
And if you go to ideaillinois.org and go to under our professional or under our Learn tab, NextWaveSTEM is in there. We do also have some special offers through Idea Illinois. So make sure if you're going to check out that curricula that you also check out the offers that we have for you.
Yes, please do. Good question. Any other questions? I know there was kind of like a fire hose of information there for a while, but any question is a good question.
Looks like you did a pretty good job, Desmond.
Well, I am really, really grateful for the opportunity to speak with everyone today. I hope that you have an amazing time as you're exploring drones. I also will really encourage everyone to check out the chat if they have access to it. Richard is dropping some gems about drone safety and the information that you need.
We're going to go ahead and include that chat in the webinar recording that I will be emailing to everybody tomorrow morning. So you will get a recording of this webinar, as well as I will include that chat because, as you said, Richard has put a lot of great resources in there for everybody. I also put in the chat just now, if you would like a PDH credit for today's webinar, please visit that bit.ly link there and go ahead, fill out the information. The link will only be open until midnight, though, so that you guys get credit for being on the webinar, and then we'll go ahead and close that before I email the video out to everybody. So, and I guess, Desmond, did you have anything else before I do the final thank you?
No, that's it for me. Thank you so much once again to everyone who joined us today, and to IDEA for hosting us. We're hoping that you have an amazing school year and that you get those drones flying.
Great. So thank you very much, everybody, for joining us today. And thank you to Desmond and NextWaveSTEM for their vast amount of knowledge that they shared with us today about integrating drones in the classroom. As you can see, the last screen there, we do have another webinar Wednesday next week. Idea and Clever will be talking about starting the school year off with Clever and single sign-on. For both staff and students. So it's another good opportunity for you guys to get another PDH credit and learn about single sign-on with Clever. So I hope to see you there. I'll be sending out that invitation as well tomorrow. So again, thanks Desmond, thanks NextWaveSTEM, and thank you all of us for joining us. And we will go ahead and leave that chat window open for another minute or two, and then we will go ahead and sign off. Thanks everyone.